In this video, I'm going to solve this Bernoulli differential equation. As you know, that a Bernoulli differential equation has the following format: dy over dx plus p of x times y is equal to q of x times y to the power n, where n is not equal to 0 or 1. If n is 0, then it becomes a first-order linear differential equation that could be solved by integrating factor. If n is 1, this becomes a separable equation. So to solve this Bernoulli differential equation, first we need to divide both sides of this equation by y square. In that case, we get 1 over y square dy over dx minus 2x times 1 over y is equal to negative x. Now what I'm going to do, I'm going to make a substitution, and that substitution is going to be, this is going to be z 1 over y. So my z is equal to 1 over y, and then dz over dx becomes negative y to the power negative 2 times dy over dx. Then if I simplify it, I get the following: negative dz over dx is equal to 1 over y square dy over dx. Now you may notice that this is nothing but this. So this could be replaced by negative dz over dx. Now after doing the substitution, I get the following: negative dz over dx minus 2x times z is equal to negative x. Now if I multiply both sides of this equation by negative 1, I get dz over dx plus 2xz is equal to x. Now this is nothing but a first order linear differential equation that could be solved by using integrating factor. So integrating factor is going to be mu of x is equal to e to the power integral p of x dx. Now p of x is the coefficient of z, which is 2x in our case. So it's going to be e to the power integral 2 times x d of x. That will give me e to the power 2 times x square over 2, or mu of x is equal to e to the power x square. Now I multiply both sides of this equation by mu of x, which is e to the power x square. That's going to give me e to the power x square dz over dx plus 2xz times e to the power x square is equal to x times e to the power x square. Now the effect of doing this, multiplying by the integrating factor, is that the left hand side becomes the derivative of a product, which is d over dx z times e to the power x square, and the right hand side is x e to the power x square. Now I can integrate both sides of this equation. So that means I can integrate it with respect to x on the left, I can integrate it with respect to x on the right. On the left hand side, in that case, I'm going to get just z times e to the power x squared. And on the right hand side, if I integrate it, I should get 1/2 times e to the power x square plus some arbitrary constant c. Now integral x e to the power x square, it's very easy to integrate. You just do a u substitution. U is equal to x square, so it's going to give me du is equal to x dx times 2, but if I divide it by both sides by 2, I get du over 2 is equal to x dx. So it's going to be e to the power u times du over 2. That is going to give you 1/2 e to the power u, which is 1/2 e to the power x squared. That's how you do this integral. So now we have this. Now to solve this, by the way, we need to multiply both sides of this equation, okay, by e to the power negative x square. Okay, so that's going to give you z is equal to 1/2 plus c times e to the power negative x square. If I simplify it further, I get the following. Z is actually nothing but 1 over y. Z is 1 over y. So it's 1 over y is equal to 1 plus 2 times e to the power negative x square. I'm just simplifying the right hand side, divided by 2. Now, if I solve for y, I can just flip it, right? Y is equal to y of x, and that is going to be equal to 2 over 1 plus 2 times e to the power negative x square. And that is going to be your final answer or solution to this given differential equation. I hope that this discussion was helpful. Thank you very much.